Okay, this is Dr. Say again, and we'll pick back up on the second video for Chapter 1. This is ITT 340, Introduction to Mainframe Operations. So the screen that you see in front of you now may be a little confusing, but I think it will make sense over time in that you will become familiar with a lot of these terms. So I'll just go over a few of them just to get you to understand where we're going and why these terms are up here. QSAM and BDAM are what are called access method. There's another one called VSAM that is very important in mainframe technology, and by access methods we mean the logic behind the organization and the logic behind the organization and your ability to access data. And the mainframe we call files, we call them data sets. They're files, but we call them data sets. And so we'll talk extensively about data sets. So they're just methods to access data. Now the way you access data on the mainframe is much more sophisticated than the way you access data in the distributed or Wintel world. Because the whole thing with mainframe is throughput, it is input-output, so you have to get to large stores of data very quickly. And so the access methods are various approaches to that, very, very sophisticated, and we'll try to boil it down. You'll see at the bottom here where my pointer is pointing, we started with a 24-bit, so that means you've got 24 bits, and your address space is 2 to the 24th power. Whatever that size is, that's the size of your address space. Those are the individual number of bytes that you can address. All the way to now we have 64 bits, so you see that is 40 bits more. So we can access data at the petabyte scale now. So it's a lot of data, a lot of big data that you can get to very quickly. A couple of other items here. Let's look at the bottom. So languages that we use in the mainframe world. The mainframe will talk to just about any language that I'm aware of. So you've got assembler, you've got COBOL, that you may not be familiar with COBOL, but you will be. Assembler is, I think you know what assembler is, very low level, very close to the machine, very fast programming language. It's actually really not language, it's the instruction set for the operating system or for the processor that you're using, but it's just coded in words so that each instruction has a word that you tell the computer to perform that instruction. Again, fairly sophisticated. C and C++ you all took in your intro class, those of you that took your intro class here at A&T. And then these languages over here, Java, J2E, XML, HTML, are the languages that are used in the mainframe world. So we'll talk about that. Here are technologies. These are technologies that we use in the mainframe world. IMS is a very fast, what we call a hierarchical database. So when you swipe your credit card or you go to an ATM, probability is that you're accessing an IMS database. It stands for Information Management System, and there are not a lot of people that are teaching this. We intend to teach it at A&T. You can make a lot of money doing IMS data management. A lot of money in that. Another technology is called KICS. I think it stands for, I can never remember the acronym, Customer Information Control System. Yeah, that's what it is. And so again, when you swipe a credit card or use an ATM, you're probably talking to a KICS application on the other side that manages your transaction. We'll talk a good bit about KICS. NCP we really don't talk about that much in this class, so I'm going to leave that alone for now. DB2 is a database that IBM produces, and it is very much a workhorse in the mainframe world. We actually use DB2 and Linux 2 on the mainframe, and so we'll talk about that. WebSphere is a very, very sophisticated piece of middleware that sits between the interface for let's say a web portal, and it sits between an application and the back-end database. Well, actually the applications they live inside of WebSphere, and so we'll talk about that a little bit. Up here, a lot of stuff going on. JES2, JES3 stands for Job Entry Subsystem. Job Entry Subsystem 2, Job Entry Subsystem 3. They're ways that mainframe manages the sophistication of the transactions that are going in and out of the system. We'll talk about JES 2, JES 3. TSO is the operating system interface that you log in. So when you log into the mainframe, you're actually interacting with TSO. Stands for time sharing option. Prism is another very, very interesting technology. What it does is it allows the mainframe to partition, to create these partitions, these logical partitions that allow you to have separate mainframes on one physical system. Very interesting. Parallel sysplex is what you know as clustering. We'll talk about that somewhat. This top line up here in blue is the various iterations of the operating system that talks to the mainframe. We start from OS 360, we go all the way to ZOS, which is what the operating system is called now. You have FICON, which is a fiber-based connection technology, so it allows the mainframe to be connected over fiber connections. It is the standard now. This system here called SCON is an older system that is coming less in use now, so it's being phased out. We have some conversation about that. PDSE stands for Partition Data Set Extended. We'll explain to you what that is. It's the way that you physically partition the data. And flash copy is a technique that IBM uses so that you take an immediate snapshot of take an image of the data, the disk, and you can do extremely fast copies and backups. So that's very important also. One here, hyperspace, we'll talk about what hypersockets are. So I took up the entire section with this one slide, but that's okay. We're in no hurry because we have to absorb this stuff, and we will continue on with the next movie to continue on in chapter 2. I'm sorry, chapter 1. Greetings. This is Cameron Say again. These are the lectures for ITT 340. The presumption is that you're going to review these slides, these movies, before you come to class, so that you will have this material, some exposure to it when we begin our discussions in class. Our class discussions are going to focus on kind of an industry perspective in labs. So the presumption is that you're going to review them. The mainframe is a very fascinating technology, and I think you will come to agree with this fairly conclusively as these lectures go along. It is still being used. It's 50 years old technology, but it's not really, because the industry, IBM, and the software vendors who develop software for the mainframe are continuously working on the technology. IBM is continuously working on the hardware, so the technology remains relevant continuously. So the mainframe that you're using today is vastly different than the mainframe that began. However, the thing that's very important is that a program that was written in 1968 to run on a mainframe will run on the newest mainframe that IBM produces today with absolutely no problem. And there are a lot of affordances for that. So that is a big point of the viability of it, that it is 100% backward compatible, and we will begin discussing that as the class goes along. So let's look over the objectives of this chapter. This is chapter 1 that we're in from your textbook. We're going to list the ways in which mainframes of today challenge traditional thinking on centralized computing versus distributed computing. By distributed computing, I mean the Intel architecture x86, including Mac, the Mac architecture, and also including personalized devices like smartphones and tablets. And so those are distributed devices. The mainframe is centralized computing. So we'll look at the comparisons between those two types of architectures. We're also going to explain how businesses make use of mainframes and the typical uses in terms of business. A big one is transaction processing, and we will cover that fairly extensively. We're going to outline the major types of workloads for which mainframes are best suited. Workload differentiation is a big part of mainframe computing. My contention is that the mainframe is not the best tool for every job, and the industry agrees. But the jobs for which mainframes are best suited are best suited for those jobs for very, very compelling reasons. We're going to talk about the roles and responsibilities of the different jobs. We may not break it down into five, but there are a couple that we will discuss. Kind of senior administrators versus kind of simpler operator jobs. And we're going to list the mainframe operating systems. I definitely want you to differentiate the different types of mainframe operating systems. Not going to go over the terms too much. We will cover these terms in the textbook and in the lectures. I will say this in class, and I will say it in the movies. The exams and the quizzes, you will have a lot of quizzes, are coming directly from the textbook. So the slides in and of themselves will give you some background and give you some familiarity, but they're not intended for you to understand the technology comprehensively. You have to be able to go into the textbook and understand what's going on. You may find it a little challenging and a little daunting at first, but I assure you, after a couple of readings, the fog will somewhat lift and stuff will start making sense. This is a very logical, very well designed technology, so you won't have too much of a problem um, absorbing it. And we're not really doing a deep dive this term, but there is a lot to cover, so be advised. This date is very important. April 7th, 1964, Poughkeepsie, New York, was the announcement of the mainframe. Let me be clear about the term mainframe. Mainframe was a generic term that was used for all large computers, and all computers were large in the 1960s. But IBM saw the need for a general business computer that you could sell the same machine to a bunch of different companies, and that were performing the same types of work, and they saw that they would make a lot of money if they built the right machine, and they did. And the mainframe really put IBM on the map. And so right now the term mainframe is relegated to IBM's System Z. They talk about the power architecture as a mainframe to some extent, but they basically mean System Z. And we'll flesh that out as time goes on. But April 7th, 1964, very, very important date in mainframe computing. Some of these earlier slides in the IBM, this is IBM material, they're somewhat, they're sales pitches to a certain degree, so I'll try to navigate around that. But be advised that things like processor technology, system performance, clustering, uptime, downtime, and disaster recovery and disaster tolerance are a very important reason why mainframes are still being used. These are very, very important characteristics of the mainframe, so keep that in mind. Even though this is something of a sales pitch, this slide is as true today as it was in 1964. Okay, we'll stop here. I want to keep the segments to between 5 and 6 minutes so that you don't get burned out, and we'll continue on with the rest of the chapter in the next slide.